Hello students, welcome you all to the session of Engineering Mechanics Set 2 GATE 2022 Solutions for Mechanical Aspirates. Moving on to the very first question. A square plate is supported in 4 different ways with the configuration P to S as shown in the figure. A couple moment C is applied on the plate. Assume all members to be rigid and massless and all joints to be frictionless. All support links of the plate are identical. Option P, 3 hinges and there is some couple in the clockwise direction. Again, the hinge positions are different with option Q. R, 2 hinges only, and S, there are 2 hinges in the clockwise moment. The square plate remains in equilibrium in its initial state for which or more of the following support configurations: A, configuration P, B, configuration R, C, configuration Q, D, configuration S. Basically, the given links provide an axial force on the plate, right? Axial forces. Given you will be having axial forces. So whenever I draw a free body diagram for P, a free body diagram is like this is the plate. There is one reaction force here, one reaction force from this side and one reaction force like this. If you see the diagram, the reaction 1, 2, 3 and a couple, that is R1, R3, R2. This is the condition. And obviously you have a couple clockwise as I told you. This is the condition of P. Coming to Q. Q has 4 hinges most. 1, 2, 3, 4. The directions are very important. If I draw for it, this is the condition. So basically the reactions are like this: R1, R2, R3 and R4 depending on the diagram, and always a clockwise moment for Q. Now when we see for R, there are only 2 supports. These are the supports in this way with reaction R1, reaction R2, couple C, and finally S. For S, only 2 supports in the inclined condition. This is the block. This is the condition R1, R2, couple. So for configuration P, reaction R1, R2, R3 are concurrent and at the centroidal point, right? Which cannot produce balancing moment about the centroid. So equilibrium is not possible for P. So whenever in rest conditions of the configuration, moment can be provided with the given reactions. Hence the equilibrium is possible for Q, R and S. So the answer will be Q, R and S. B, C and D. Multi-select questions is this. B, C, D. All these are the right answers for the given question here. Moving to the next question. The length of member BC and CE in the frame is shown in the figure are equal. All the members are rigid and lightweight and the friction of all joint is negligible. 2 forces of magnitude Q is greater than 0 are applied as shown in the figure, each at the mid length of respective members on which it acts. So this is A hinge, B link, C link, D hinge, F is a hinge again, E is the link, H hinge and G is the point. Q is the force which is acting on the member. Which one of the following member do not carry any load force? AB, GH, CD and EF. This is the question given to you. So before going into the condition, I'll take GH link. Okay, like G is a slot there which can be moved, hence the force provided by member BE, this condition BE will be perpendicular to the member. This is the condition for suppose I take an FBD of G and H. We have a reaction force at G, RG, and you have a horizontal and a vertical condition H suffix H. Repeating, we have a horizontal condition H suffix H, V suffix H. So when we take moment about the point H, what happens? The force at member AB, CD and EF of the link members, hence they carry only an axial loads. By the moment I can clearly say RG will be is equal to 0, that is reaction at point G. When I draw a free body diagram for the given question with the straight links, FAB where the force is acting outward, Q force acting at the center, obviously the length will be L by 2, FCD the force acting outward. I am taking all the forces outward depending on the directions, I mean positive or negative sign. In the end I will decide. This is L by 2 and EF is the condition. And so from this condition, this is the force which is coming out. Summation of horizontal force is equal to 0. FAB is equal to Q. When I take moment about E and equate it to 0, force into perpendicular distance. So what happens? Minus Q into L by 2 plus FCD or DC into L by 2 plus L by 2 is L, minus Q into L by 2 plus FAB into L, which shall be equal to 0. But we know that FAB is equal to Q. Now FCD will be is equal to 0. Summation of Fy is equal to 0 if you do, E you will be getting FEF, the link EF is equal to Q. Hence the CD and GH members carry 0 forces. EF is equal to 0, CD is equal to 0. Now what will the answer be? CD and E, GH is B. So all the members GH and CD will have no load or do not carry any load. Option B and C, multi-select question again here. Option B and C will be the right answer for the given question. These are the questions from 2022 GATE afternoon paper for mechanical students. Thank you.